Okay, let's look at this question 9.3 now. So you have an electric cart, okay, and it moves inside a vertical circular track, okay, and the speed is constant at 28 kilometers an hour. So 28 kilometers an hour, you convert to meter per second is 7.78. All right, the radius is 2.5 meters, okay, and the part A is asking for the maximum normal reaction of the track acting on the cart. So the first thing is very important. You have to imagine the cart. Okay, the track is actually not important because when you draw a free body diagram, your so-called body is the cart. Okay, and then you ask yourself, what are the forces that is acting on the cart? Again, you have a top and bottom position. How would you draw the forces? At the top position, right, you have your weight, correct? And because the cart is resting on the track, and the diagram is actually very important, okay, because if the cart is actually sitting on top of the track, right, the reaction will be different. So for this case, the reaction is actually also pointing down, okay, and your second law would then be mg plus r equals to mr omega square. Okay, or in this case, since we have velocity, right, so we might as well use mv square over r. Okay, so the question is the normal reaction. Okay, this reaction, right, would be, if this is the top position, would be mv square over r minus mg. Okay, if you look at the bottom position, the forces will look like this. You have mg, okay, reaction is pointing upwards. So remember, this is the top, so the bottom would be what? R minus mg equals to mv square over r. Okay, for this case, then the reaction would be mv square over r plus mg. Okay, so naturally, you will pick this as the maximum reaction. Okay, so it would be 12, 7.78 square over 2.5 plus 12 times 9.81. Okay, the answer is 408.3 newtons. Okay. Now, the next question is the least cart speed in order not to fall off the highest point on the track. So, it's already telling you at the highest point already. So you imagine yourself at the highest point. This is the equation of motion, right? So when it says that not to fall off the track, meaning there is no reaction from the track on the cart. Okay, so r is equals to 0. Okay, so it means that mv square over r equals to mg. Okay, so cancel away the mass. My velocity equals to gr square root. .95 meter per second. Okay, in kilometers an hour, it would be 4.95 times 3600 over 1000. 17.83 kilometer an hour. Okay, so the idea is the same. You take the positions, okay, you identify the direction of the forces, and you form the equation of motion. Okay, you form the correct equation of motion.